We're going to start with the first learning target quiz, and one of the first vocab terms we learned was reference points. A reference point is any object that you can measure the distance between where you've traveled and where you began with. The first question says, which of the following would be a good reference point and why? So when you look for a good reference point, you need to look for something that can't move. So the good reference points in this picture would be the tree and the door and the Wall Street sign. The reason why a car and a dog would not be a good reference point is because they can move, and if they move, you don't know what the distance between you and the other object would be. All right, the next question, we're looking at distance versus time graphs. So it says, La Mama is traveling from her physical science class to English. She walks out of physical science, but she drops her pencil. She stops, picks up her pencil, and then begins to move to her class. When she gets to class, she sits down in her seat. So I want you to calculate three things: average speed, speed from letter C to letter D, and speed from D to E. When you're looking for average speed, you need to look for the total distance divided by total time. And if you look for the total distance on the graph, you look at the very final letter, and E is the last letter, so we're looking at this point. At E, the distance is 4, and at E, the time is 40. So what you're going to do is you're going to take total distance divided by total time, take 4 meters divided by 40 seconds, and that would be your average speed. So the answer for average speed, if I can flip the slide, would be 4 divided by 40 is 0.1 meters per second. The next question I wanted you to answer was, what is her speed from point C to D? To find that, you have to first find her distance at D. Her distance at D is 4 meters. And then you have to find her distance at C. And her distance at C is between 1 and 2. So technically it's 1.5. Now to find the distance between 1.5 and 4, you have to subtract, and you take 4 minus 1.5. And that gives you that her distance that she traveled from point C to D is 2.5 meters. Then there's two parts to calculating speed. The other half you need is time. You have to look for her time at D. Her time at D is 30 seconds. Her time at C is 20 seconds. So just like we did for distance, you have to take 30 seconds minus 20 seconds, and that's going to give you 10 seconds. So remember that speed equals distance divided by time. So if you take 4 minus 1.5, you divide all of that by 30 seconds minus 20 seconds. And when we simplify this, we're going to get 2.5 meters divided by 10 seconds. So you should have gotten 0.25 meters per second. The last question I had was, what is her speed from D to E? Now there's two ways you can approach this question. At D, you can notice that her distance is 4 meters. At E, her distance is also 4 meters. If she hasn't moved any distance since where she was at 30 seconds, meaning at 30 seconds she was 4 meters away, and at 40 seconds she was still 4 meters away, it means she hasn't moved. And if you haven't moved anywhere, your speed is 0. The other way you can do this is you can do the math to find out what her speed is. So you do the exact same as the last problem. You look at E. At E, her distance is 4. At D, her distance is still 4. 4 minus 4 is 0. Then you look for time. At E, her time is 40. At D, her time is 30. 40 minus 30 is 10 seconds. So we have to do a little bit of math. We're going to take distance divided by time. I take 4 minus 4, all divided by 40 seconds minus 30 seconds. So you'll get 0 meters, and that should say divided by 10 seconds gives you 0 meters per second, because 0 divided by any number gives you a 0, so she wasn't moving. Next question is an analysis question for the graph. It says, between what 2 points is La Mama traveling the fastest? When you look for the fastest speed on a distance versus time graph, you're looking for the slope of the line, or where the line is going up the most, which is from C to D. It's going a little bit further up than A to B. The other way you could find this is by knowing that from C to D we said it was 0.25 meters per second. From D to E we know that her speed was 0 because we just calculated this. From B to C we also know her speed is 0 because the line is flat. meaning she didn't travel anywhere. Her distance at both B and C is 1.5. At A to B, if you calculated this, you should get 0.1 meters per second. And looking at these numbers, to find the one that's fastest, you look for the numbers that is the largest. 0.25 is larger than any of the numbers. Think of this as like 25 cents. And 0.1 is only like 10 cents. I think this was actually 0.15 meters per second, but 0.25 is still bigger. So we know on this graph, La Mama is traveling the fastest from letter C to letter D. So it's up to you if you want to do the math or if you want to just look at the lines on the graph. Either way is fine. The next question says, between what 2 points is La Mama traveling the slowest? We know from our past questions that there was a point in time on here that La Mama was not traveling at all, and the slowest speed anyone can be going is 0. So we know that from D to E she was going 0 meters per second. From B to C she was also going 0 meters per second. Those are both the slowest times. Remember, on a quiz or a test, I only give you one option. You would never have one where you have 2 different points that are both traveling the slowest. Is La Mama's velocity changing? Why or why not? There's 2 different pieces to when velocity is changing. You can change your speed or you could change your direction. Now, since this is a distance versus time graph, we never know if she changed direction. Now, chances are she did, but you can't prove it to me on the graph. If you look at the graph though, from A to B she's going 0.15 meters per second, B to C she's going 0 meters per second, C to D she's going 0.25 meters per second, and D to E she's going 0. Knowing that your numbers changed, prove that her speed changed. You also know her speed changed because this is not a straight line. If it was a straight line, her speed would be constant, and you could say that her velocity is constant given the information. Since we know that her velocity changed, you can also say that La Mama accelerated, because anytime your velocity changes, whether it's speed or direction, you accelerate. And that answers that question. Moving on to the difference between speed and velocity. So it says Hassan moves from point A to B to C. So he travels down the side of the triangle and over to C. It does not ever say that he goes back to point A. It ends at C, starts at A. So when you look for his distance, you're looking for where he actually walked. He walked on this orange line, which means that to find the distance, I need to add 4 plus 3. And if you add 4 plus 3, you should get 7 meters. To find the speed, you're going to take your distance divided by time, because we're using this equation up here. Take 7 divided by 245 seconds, and you get 0.05 meters per second. There's no direction for speed. If you have a direction on there, that's fine, but you don't need it. When we look for a velocity, what we need to do is look for displacement, and displacement is only the distance from start to finish. If you look at the letters, he starts at A, which is here, and he ends at letter C. So we're only looking at a straight line from A to C. That's given to you. That's 5 meters. On a quiz or a test, you're expected to be able to use a ruler to calculate that, to measure it. But I gave you the easy way out here. It's 5 meters. So the displacement is 5 meters. Velocity is displacement divided by time. You're going to take 5 meters divided by 245 seconds, which was given to you, and that equals 0.02 meters per second. And since it's velocity, you have to have a direction that is southeast. And how I found southeast is that he starts at A, he ends at C, which means he's walking this direction. When you use a compass over here in the right side, start in the middle and draw a line exactly like the one that looks like, or the direction it looks like it's going. So he's going down and to the right. If it's going down and to the right, you would start with either north or south. He's closer to south, we're going to put south, and it's between south and east, southeast. Does Hassan accelerate? To answer this question, you have to think, does his velocity change? We don't know enough about the problem to know whether or not his speed changes, but if you look, he walked from A to B, and then at B he has to turn to the right, which means that his direction changes. If your direction changes, your velocity changes, which means that he accelerated. Next question says, Tim travels from home to school in 32 seconds. So here's Tim at home. Here's Tim at the school. You follow the footprints over here. Remember, the distance is only where he walked. So look at the footprints. He walks to the right for 4 meters, then he walks up for 3 meters, and that's his total distance to the school. To find his total distance, I need to add those numbers. 4 plus 3 is 7 meters again. Then to find the speed, I'm going to take my distance divided by time. Distance is 7 meters, that's what you just calculated, and time is 32 seconds. Take 7 meters divided by 32 seconds, and you should get 0.22 meters per second. Again, this is speed, you do not need a direction. To find displacement, you only look from start to finish. Tim starts at home, he finishes at school. I gave you the straight line from start to finish. It says 5 meters. So his displacement is 5 meters. And to find velocity, I'm going to take displacement divided by time. 5 meters divided by 32 seconds equals 0.16 meters per second northeast. The reason I found northeast is he starts here. So look at your compass. He starts in the middle, and he goes up and to the right. Up and to the right is between north and east. So I'm going to write this as northeast, or just capital N, capital E. Does the sun accelerate? Same as the last question. We don't know if his speed changed as he walked to school, but we do know that his direction changed when he turned the corner. Like when you're walking to school and you take a left or you take a right, your direction changes, so we know that he accelerated. All right, moving on to Learning Target 2 quiz. So this is resultant velocity. Resultant velocity, when you do these problems, if they're going in the same direction, you need to add the two numbers. If they're going opposite direction, you need to subtract. So you are walking on a bus. The bus is moving left at 12 miles per hour, and you are walking left at 2 miles per hour. Left and left mean that those are the same direction, so I should be adding these numbers. 12 plus 2 is 14. The unit is already on there for you. It's 14 miles per hour. I pick the direction. If they're the same, you would use the direction you're given. So both are going left, you would use left. So they're going 14 miles per hour left. Taylor Swift is running left at 2.2 meters per second. The treadmill is moving right at 4 meters per second. If you notice, right and left are opposite, meaning that I should subtract these two numbers. I'm going to take 4 minus 2.2, and that would give you 1.8 meters per second. How you pick the direction. When you have opposite directions, you need to look for the bigger number. 4 is the bigger number, and that is going to the right, so your final direction is right. So 1.8 meters per second right. So as you can see, Taylor Swift should fall off the treadmill. You are walking on a bus. The bus is moving right at 30 miles per hour, and you are walking left at 10 miles per hour. Opposite directions. One is going right, one is going left. Subtract. 30 minus 10 is 20. You take the direction of the larger number. The larger number is 30, and 30 is moving to the right. So you should get 20 miles per hour right. Dogs run forward on the treadmill at 4 meters per second. The treadmill moves backward at 4 meters per second. Those are opposite directions, forward and backward. So you're going to take 4 minus 4. 4 minus 4 is 0. 0 meters per second. And if it's 0, they don't have a direction, so technically they're going nowhere. The escalator is moving left at 3 meters per second. Superman is moving left at 0 meters per second. Both of these are moving left, so you would add. 3 plus 0 is 3 meters per second. Since they are both moving left, you take either of the directions that's left, so he should be moving 3 meters per second left. The escalator is moving left at 3.5 meters per second. The woman is moving right at 4.2 meters per second. Right and left are opposite directions, so you need to subtract those two numbers. So take 4.2 minus 3.5. And that gives you 0.7 meters per second. The direction is right because 4.2 is a larger number than 3.5. All right, moving on to acceleration questions. Acceleration, you have a very specific formula to follow. Some things that I've noticed in class is that a lot of you don't take final first. No matter what the final number is, whether it's the bigger number or not, you have to take the ending velocity. So generally the second number for velocity that I give you. Final velocity minus starting velocity, all divided by the time to change velocity. So this question reads, a car's velocity changes from 0 to 30 meters per second. So that means that its starting velocity was 0. That's the first number I give you. The ending velocity is 30. So when you set this up, you're going to take 30 minus 0, all divided by the time to change velocity. So I'm going to divide it by 10. You have to simplify this before you put it into your calculator. You would take 30 minus 0, which is 30, divided by 10, which would give you 3 meters per second. Which means that every single second that car drives, so at 0 meters per second, 1 second later, it should be going 3 meters per second. Another second later, it should be going 6 meters per second. And another second later, it should be going 9 meters per second. So it speeds up 3 meters per second every second. It's positive because they sped up their speed from 0 to 30. The number got bigger. It's also positive because you got a positive number on your calculator. There's 2 ways to check your answers. A cheetah running at 75 miles per hour slows to 0 miles per hour in 0.01 hours. The final velocity is that second number. He slows down to 0 miles per hour. So I would set it up with 0 miles per hour in the beginning minus my final velocity, minus my starting velocity, which is 75, all divided by time. And the time is 0.01 hours. 0 minus 75 gives you negative 75 on your calculator. Take a negative 75 divided by 0.01. It will give you negative 7,500 miles per hour per hour. It's negative because it's a negative number. It's also negative because they slowed down. They go from 75 miles an hour to 0 miles per hour in a very short amount of time. A satellite's starting velocity is 10,000 meters per second. After 60 seconds, it is going 5,000 meters per second. What is the acceleration? Take final velocity minus starting velocity. The final number is 5,000 for velocity. I'm going to take 5,000 minus 10,000, which should give you negative 5,000, all divided by 60 seconds, because that is our time. So take negative 5,000 divided by 60. That gives you negative 83.3 meters per second. And that's a negative number. You also know it should be negative acceleration because 5,000 minus 10,000 is negative 5,000. They are also slowing down. If you go from 10,000 to 5,000 meters per second, you slow down 5,000 meters per second. The man on the Segway is traveling at 1 meters per second, and after hitting Usain Bolt is traveling 0 meters per second in 5 seconds. His final velocity is 0 meters per second. His starting velocity is 1 meter per second, and his time is 5 seconds. So I will take 0 minus 1 divided by 5 seconds. That's negative 1 divided by 5, which gives you negative 0.2 meters per second. And it's negative acceleration because it is a negative number when you put it into your calculator. He also slows down to a complete stop. A raccoon moving at 0 meters per second jumps to a velocity of 3 meters per second in 1 second. In this case, the final velocity is 3 meters per second, so I take 3 minus 0, all divided by 1. 3 minus 0 is 3, and 3 divided by 1 is still 3, so it's 3 meters per second. It's positive because he speeds up from 0 to 3 meters per second. A plane traveling at 20 meters per second slows to a speed of 2 meters per second in 45 seconds. You take 2, which is the final, minus 20, which is the starting, all divided by time, which is 45 seconds. And he slows down, so this number should be negative. So if you take 2 minus 20, you should be getting negative 18 meters per second divided by 45 is negative 0.4 meters per second. It's a negative number, and they slowed down. The next type of graph we're going to look at is called a velocity versus time graph. You can also look at a speed versus time graph, and they are virtually the same graph because you cannot tell the direction that someone is moving based on a graph. So if you look at this graph, if I look at the first line, I'm ignoring the blue line. I'm going to look at the red line. At the red line, if you look at the very first line, when time is 0, velocity is 0, meaning they are not moving. Look at the end of the graph where this line is stopped. At 4 seconds, the velocity is 8 meters per second. So this person traveled from 0 meters per second to 8 meters per second. This is positive acceleration because they speed up. The next line that we're looking at the top of the line, this says 8 meters per second. At the end of the line, they are still traveling at 8 meters per second. Since their velocity does not change, there is no acceleration, and we call this constant velocity. Looking at the last red line, at the top of the line, they're traveling at 8 meters per second. At the bottom of the line, they're going 0 meters per second. If you travel from 8 meters per second to 0 meters per second, you are slowing down because you're coming to a complete stop, and that would be considered negative acceleration. If you calculated this on your calculator, how we did in class, you should also be getting a negative number. And we'll have a couple examples of that later in the review. So we're going to do a couple examples, like things you might see on the test. It says Trung speeds out of his driveway. Then he maintains a constant speed of 10 meters per second. He then needs to stop at a stop sign for 3 seconds. He then speeds up and continues to drive at a constant speed. So here's the graph, just a closer view. When is his speed constant? A time when speed is constant is when his speed is not changing. You can tell that from 0 to A, his speed is changing because it goes from 0 meters per second to 10 meters per second. From A to B, his speed stays 10 meters per second. If you look at A, it's 10. If you look at B, it's still 10, meaning his speed was constant. So one possibility was from A to B. There's more than one for this graph. From C to D, his speed is 0 and does not change. From E to F, his speed is also the same. It stays at 5 for E and F, so his speed is constant. There are 3 points. When is his speed 0? On a velocity versus time graph and a speed versus time graph, you're not looking for where the line is flat. But you do need to look for where the speed is 0 by looking at the left-hand side, because that's where speed is on our graph. It's on the y-axis. So here's speed. Here's the number 0. You'd look at any point where it matches that part of the graph. O is a part where his speed is 0. At C, his speed is 0. And at D, his speed is 0. Now, if you use what you know about speed, if your speed is 0, it means you're stopped. So technically, these two questions are asking the same thing. He stopped at O and C and D. Positive acceleration is when someone is speeding up. Their velocity number or their speed number should be also going up. So if you look from O to A, his speed goes from 0 meters per second to 10 meters per second. So he is speeding up. Same from D to E. At D, his speed is 0. At E, his speed is 5. So he speeds up at 2 different points in this graph. He speeds up from O to A and D to E. When he is negatively accelerating, he should be slowing down. You look for where the graph is pointing back down again. At B, his speed is 10 meters per second. At C, his speed is 0 meters per second. So he slows down from 10 to 0 meters per second, coming to a complete stop between C and D. So there is only one point on this graph where he's negatively accelerating. That would be between point B to C. Remember, on a test or a quiz, you only have one that should be the correct answer. When is he driving the fastest? You are not looking for where the line is pointing up the furthest, but you're looking for where the speed number on the side should be the highest. The highest speed you look at on the side, the biggest number is 10. And then you can look across at your graph to see which points match up with 10. That would be points A and B. So be between A and B is when he is driving the fastest. What is Trung's acceleration from A to B? Now this is similar to the distance versus time graph. If you look at your equation for acceleration, you take final velocity minus starting velocity, all divided by time to change velocity. So I would start with my final. If I'm looking at A to B, the final one is B because B comes after A. B's velocity is 10, A's velocity is 10, I would take 10 minus 10, which is 0, divided by time. The time at B is also 10 seconds. The time at A is between 4 and 6, so that is 5 seconds. 10 minus 5 is 5 seconds. So I would take 0, because that was 10 minus 10, divided by 5 seconds, and 0 divided by any number should give you 0 meters per second, which means that his velocity is constant and there is no acceleration. What is Strong's acceleration from D to E? To find the final velocity, look at E. Here's E. At E, his speed is 5 meters per second. Then you need to look for his starting velocity. His starting velocity, we're looking at point D, is 0. So I'm going to take final minus starting. Final would be 5 minus starting is 0 divided by time. And time to change between D to E, you need to take a look at the bottom half of your graph. His E matches up with between 20 and 22, which would be 21. D is exactly at 16, so I'm going to take 21 minus 16, and that's 5 seconds. So 5 minus 0 divided by 5. So 5 divided by 5 should give you 1 meter per second per second. The reason it's a positive number is because from D, he speeds up from 0 meters per second to 5 meters per second. So if he speeds up, it's a positive number, and that's just an easy way to double check your work. What is Strong's acceleration from point B to C? At B, his speed is 10 meters per second. At C, his speed is 0 meters per second. So I'm going to take the final number. C comes after B. So at C, his velocity is 0 minus his starting velocity at B is 10, all divided by time to change velocity. To find this, I'm going to look at C, and I know this is kind of covered up, but if it's between 12 and 14, this should be 13 seconds. At B, his time is 10. To find the amount of time between B and C, I need to subtract, just like we've been doing before. 13 minus 10 is 3 seconds, so I'm taking 0 minus 10, which is negative 10, divided by 3, and that should give you negative 3.33333, repeating, meters per second per second. Just keep in mind that you should be rounding to 2 numbers after the decimal place. It's also negative because from B to C, they slowed down. This is a review for a vocab word, and my animations are not quite working when I'm presenting this, but technically Justin Timberlake should be spinning in this picture. It says, what kind of acceleration is this? When you're spinning and you're accelerating because your direction is constantly changing. Like if you spin, you look in different directions. If your direction changes, your velocity changes. And if your velocity changes, you accelerate. The kind of acceleration this is when anything is spinning, so fan blades or an ice skater or anything spinning, is centripetal acceleration, and that's in your note packet. All right, the third learning target quiz, so the last one we took last Friday. So most of this should be fresh in your minds. When we find net force, it's very, very similar to the resultant velocity. If things are going in the same direction, you should add. If they're going in opposite directions, you should subtract. So the net force is a combination of all forces acting on an object. So you have to add or subtract every single number given to you. So on this first box over here, 3 and 5, 3 is going to the left, 5 is going to the right. Those are opposite directions. You should be subtracting those two numbers. 5 minus 3 is 2 newtons, and that's to the right because 5 is a larger number, meaning this box should move to the right with 2 newtons of force. The next question says you have someone pushing on the box with 5 newtons of force to the right, another person on the box pushing to the right at 5 newtons. Those are going the same direction. They're both going right. You should add. 5 plus 5 is 10 newtons to the right. And this should also be moving because this is an unbalanced force. The next question has 2 people moving a sofa. One person is pushing with 25 newtons and the other is pulling with 20 newtons. They're both going to the right. I should add 25 plus 20 is 45 newtons to the right. The next question is a little bit more complicated. You have to look for which ones are opposite of each other. North and south are opposite, so I'm going to subtract 15 minus 10 would give you 5 newtons south because 15 is a larger number. You do not have anything opposite of east, no one is pulling to the west, so you keep it as 5 newtons to the south and 20 newtons to the east. And if you wanted to convert that into an angle, that is something you would do in an upper level physics class, but not in our class. When we're looking at net force, we do need to find if the force is balanced or unbalanced. If it's balanced, that means that it will not move. It will stay in the same spot. The net force should be 0. So if the net force equals 0, forces are balanced and the object will not move. If net force does not equal 0, so you get 1 or 5 or 200, any number other than 0, the forces are unbalanced and the object will move. So if you look at this first picture, you have two cats sitting on a weight scale. One is pushing down on this side with 200 newtons, and the other cat is pushing down on the right side with 200 newtons. They're both pushing down 200 newtons on opposite sides of the board, so technically they would be balanced. And net force would be 0. The next question, you've got someone pulling on a box with 3 newtons to the left, 2 people pulling on the box to the right with 4 newtons each, meaning I should add 4 plus 4 and get 8 newtons. Subtract 3 newtons because 3 newtons is pulling to the left. 8 minus 3 is 5, and that is 5 newtons to the right. So this is an unbalanced force because the object should move to the right. The next question, starting on the bottom and working our way up. They're pulling with 400 newtons to the left, and the other 3 people are pulling to the right with 300 newtons. Those numbers are not the same. They're going in opposite directions. I would subtract 400 minus 300 is 100 newtons. To the left because 400 newtons is a bigger number. The picture above has someone pulling to the left at 300 newtons and 3 people pulling to the right at 300 newtons. Those numbers are the same. If I subtract, I should get 0 newtons. And anytime you get 0 newtons, that's a balanced force and they're not going to move. The object at the right side is similar to the last one we did on the last page. You look for the ones that are opposite of each other. 2 newtons and 2 newtons, so north and south, are opposite. 5 newtons left and 5 newtons right are opposite. So I would take 2 newtons minus 2 newtons means it's not moving up or down. 5 newtons to the left and 5 newtons to the right. 5 minus 5 is 0. So technically this object is balanced, although there are 4 forces acting on it, and the net force is 0. When we look at friction, friction is a force that opposes motion, meaning it does not want an object to move. This is why it's really hard to push on objects that are really heavy, because if they are heavier, they have more friction pushing down on them. So if you look at the boxes on the bottom and think back to what we learned in our metrics and mass unit, 5 grams is a larger number than 8. Or sorry, 5 grams is a smaller number than 8. If you have a smaller number for mass, that means you have less weight, meaning it's easier to push that box because it has less friction between the box and the floor. The 8 grams has more friction because it has more mass, more weight, harder to push, more friction. The 2 pictures at the top has a picture of an icy road and a picture of a tarred road. When something is icy, it has a very smooth surface similar to the picture on this side. It's easier to push an object on a smooth surface, so it has less friction. There's less of a force opposing you or pushing you back when you try and push forward. With a rough surface, it has many, many grooves that it can catch on. It's difficult to push something on a rough surface. Think about pushing like a cart on carpet versus on a wood floor. It's harder to push it on carpet because it has more friction from the rough surface of the carpet. So looking at our 2 different terms for friction, you have 2 different kinds. There's kinetic friction and there's static friction. Kinetic friction means something is moving. Static friction means something is not moving. So you're pushing on an object, you're exerting a force, but static friction is so strong that you cannot overcome static friction. It's not going to move. In this first picture, I know you can't see that it's actually moving, but the football player or the baseball player is sliding. If you're sliding, you're moving, and that would be kinetic friction. This animation doesn't work, so I'm going to skip these while we're in the PowerPoint mode, otherwise they don't make sense. This girl would be straightening her hair if you could see the animation. If you straighten your hair, you're moving your straightener down your hair, which means if it's moving, it's kinetic friction. In this picture, there was the 8 pushing on the scientist who fell over on a table. The ape could not get the cart to move. He was pushing really hard, but it was not moving. That was static friction. If you sled down a hill, you should be sliding down the hill unless something is wrong with your sled. And if you're moving down a hill, that's kinetic friction. If you had one person pushing on a car, and let's assume that the car is not moving because it's a really heavy car, this would be static friction. If he could get the car to move, that would be kinetic friction. All right, our last topic for the entire unit was gravity and the universal law of gravitation. Along with this, what we did is we calculated weight. Weight is your force that you exert on the ground due to your mass and due to gravity on Earth. So first off, we're going to calculate what our weight would be on Earth. When we do this, we need to take our mass in kilograms because newtons, which is our unit for weight, is in terms of kilograms. So I'm going to take weight equals mass times gravity. We're assuming that your mass is 78, so we're going to take 78 times the acceleration on Earth due to gravity, which is 9.8 meters per second per second. This means that if I drop any object, every second that it's falling, it should theoretically speed up 9.8 meters per second. So 2 seconds later, it should be going 9.8 times 2, so close to around 19 meters per second. So I'm going to take weight equals 78 kilograms times 9.8 meters per second per second. Your weight would be 764.4 newtons, or you could also say the 764.4 kilogram from mass, meters per second from gravity. The one that we use most often in class, though, is newtons, and that is the unit that would show up on a test. Then what we're going to do is calculate your weight on our moon. The other name for our moon is called Luna, and the acceleration of gravity on Luna is called 1.63 meters per second, meaning that if I drop something, it only speeds up about 1.63 meters per second every second, which is much, much slower than on Earth. Our mass does not change because the amount of stuff that you are made of does not change unless you considerably gain weight or something else before you go to the moon, which we're going to assume is not happening. So we're going to take weight equals mass times gravity. Your mass doesn't change. Like I said, we're going to take 78 kilograms times the gravity on Luna, which is 1.63 meters per second. And you should calculate this to be 127.14 newtons, or you could say 0.14 kilogram meters per second. Like I said, we don't really use that very often because it's very wordy when we can just say newtons, because weight is a force. Now, if you look at these two different numbers, 127.14 newtons is much, much smaller than your weight on Earth. The reason for that is, using the universal law of gravitation, these pictures are not to scale. But keep in mind that the mass of the moon is much smaller than the mass of the Earth. Because the mass of the moon is so much smaller, remember from the universal law of gravitation, when your mass decreases, your amount of gravity decreases. And if they can't pull as hard on you on the moon, like the moon is not pulling as hard on you as Earth, meaning you could jump really high and you'd kind of float in air for a little bit, you don't weigh as much on the moon. However, your mass is still the same. So thinking about this compared to the largest or most massive star we have in our solar system, that is the sun. The acceleration of gravity on the sun is 274 meters per second, which is way, way bigger than that on the Earth. Meaning if I dropped a pencil, 1 second later it's going 274 meters per second. That could do a lot of damage. So I'm going to take my weight equals mass. My mass is 78 kilograms times 274. Your weight on the sun is 21,372 newtons, which is incredibly heavy, meaning that you could not jump on the moon, or on the sun. You probably couldn't even move your legs. And in reality, you probably wouldn't be able to survive on the sun. You would melt and you would burn if you even got close enough to the sun. So in reality, this can't really ever happen. We're going to compare your gravity on the sun compared to another planet. We're going to look at Neptune. Neptune's acceleration of gravity is 11.15 meters per second. This is a bigger number compared to Earth. Earth is 9.8, which is something we're going to use a lot next chapter. But it's bigger because Neptune is more massive, meaning it has more mass, which increases its acceleration due to gravity. So just like before, I'm going to take weight equals mass times gravity. Weight equals 78 kilograms times 11.15 meters per second, which gives us 869.7 newtons. Or you can say it's kilogram meters per second. This means that you weigh a little bit more on Neptune, but your mass did not change. Now just applying what we know about the gravitational force and the universal law of gravity, any time that you increase your mass, so like if you think back to our weight on the sun, our weight on the sun was incredibly heavy. That's because the sun is so massive. Now this picture is not to scale. If this was the sun, the Earth would really, in reality, be this tiny little spot of purple. That's how small the Earth is compared to the sun. The sun looks so small because it's so far away. The Earth is actually 149.6 million kilometers away from the sun. So remember, this picture is not to scale. Our moon is only 384,400 kilometers away from Earth. So if you look at Earth, Earth has a bigger mass than our moon, which is pretty obvious looking at the pictures. So our moon rotates around our Earth like this, not going only around the sun. It rotates around Earth first because gravitational force increases as mass increases. So Earth has a bigger mass than the moon. The reason it goes around the Earth and not just around the sun is because it has a really small distance between the Earth and the moon compared to the Earth and the sun. However, our moon rotates around the Earth, and then it will also rotate around the sun because every single planet and star does rotate around the sun because the sun is the most massive star in our solar system, meaning that everything else rotates around it. And those GIFs aren't working, so I'm not going to spend a lot of time on those. Another example, so Neptune has another moon, that's why we call Luna the name for our moon in this presentation. Triton is a moon. Triton is only 354,760 kilometers away from Neptune. Neptune is 4.498 billion kilometers away from the sun. Since Triton is so close to Neptune and it's so much smaller than Neptune, Triton does rotate or revolve around Neptune. It spins at the same time, so it rotates and technically also revolves. Neptune, however, if you compare Neptune and the sun is definitely more massive. Many times more massive. Similar to the pinhole. It's just Neptune is tiny compared to the sun. Neptune will also rotate and revolve around the sun with time as Triton continues to go around and around and around. Triton can't follow its own path because the force of gravity is much greater on Neptune compared to Triton. If you need to go back and look at anything in the presentation, you can just press pause or go back and open it back up again. Hopefully it's helped you out. And don't forget to have your pink note packet done for tomorrow. Good luck studying.